So hey guys, very good evening everyone and welcome to another session of domain analytics, which is being planned, being executed by 360DigiTMG. And in this particular domain analytics, since past few days, we have been talking about cyber security analytics. We discussed a lot of things. We discussed about, k-means clustering, EDA, data preprocessing, what is cybersecurity analytics, what are the various uses or how we can, implement our data science knowledge when we talk about cybersecurity as in various type of attacks and all these stuff we have already been talking about. So today's agenda is that today we will be discussing about KNN, that is your K nearest neighbor algorithm, and its use in cybersecurity. Before that, we'll be discussing about what is KNN. Gradually, we will, move ahead with our learning, and then I will be showing you the analysis which I have done on the network traffic classifier. And here I have tried to find out various inferences. I have used, KNN to find out various inferences about this particular classifier, various kind of threats that have been occurring. All these things I have tried to identify. I have also tried to do a comparison between your linear regression and KNN. And I have tried to find out that which one is better. Either your KNN model is better or your linear regression is, better. I have tried doing all these things. Sorry, logistic regression I have used. And we will be discussing this once we have done understanding about what is KNN, what is its use in, cybersecurity. Okay. So when I say KNN, what does it actually mean? KNN, guys, stands for K nearest neighbor, and it is the unsupervised. No, sorry, it is a supervised machine learning algorithm. The algorithm called as KNN can be used to solve both your classification as well as your regression problem statement. Okay, let me jot it down for you guys. So it is going to help us with what? Classification as well as regression related problems. Okay. The number of nearest neighbor to a new unknown variable that has to be predicted or classified is denoted by a symbol K. What happens is, guys, that in statistics, your KNN is a non-parametric supervised learning method. And eventually it was, first developed by Evelyn Fix and Joseph Hodges in 1951. They were the one who developed the K nearest neighbor algorithm. And later it was again expanded by Thomas Cover. Basically, it is used for your classification and regression. We discussed that. Now, what happens is that in both cases, the input consists of K closest training examples in datasets. The output depends on whether your KNN is used for classification or your regression. This is what I have mentioned over here. That KNN represents a supervised classification algorithm that will give a new data point accordingly to a K number or your closest data point, which means while K means is clustering, it is an unsupervised clustering algorithm that gathers and groups data into K number of clusters. Moving ahead. Even before we discuss this, let me tell you something more about your KNN. What happens is in your KNN classification, the output is a class membership, which means that an object is classified by a plurality vote of its neighbors. How many times, suppose we are having a neighbor, and how many times it is pluralizing itself. On that basis, your object is classified. with the object being assigned to the class most common among its k nearest neighbor. K is also called as a positive integer, typically small. Now what happens is, if k is equal to 1, if k is equal to 1, then the object is simply assigned to the class of that single nearest neighbor. In KNN regression, the output is property value of the object. Property value of what? For the object. This value is nothing but the average of the values of your k nearest value. KNN, you can say that it is a type of classification where the function is only approximated locally, and all the computation that is deferred, until the time your function evaluation is happening. Now, since this algorithm relies on the distance for classification, if the features represent different physical units or come in vastly different scales, then normalizing the data, normalizing the training data, I would rather say that, can improve its accuracy dramatically. We know that. Both for your classification as your regression, a useful technique can be used to assign weights to the contribution of the neighbors. When we do that, what will happen? The nearest neighbor or your nearer neighbors contribute more to the average than the more distant one, right? For example, let us take an example. A common weighting scheme consists in giving each neighbor a weight of 1 by d. And let us consider this example, 1 by d, where d is the distance of the neighbor. Distance of neighbor. Now, the neighbors are taken from the set of objects from which the class or the object property value is known. This can be thought of as the training set of your algorithm, guys, though no explicit training step is required. Getting the point, guys? Just a moment, guys. Okay. Now, moving ahead, a peculiarity of your, KNN algorithm is that it is sensitive to the local structure of the data. Sensitive to local structure. That is its, peculiarity. When do we use KNN algorithm? We discuss all these things, that is fine. But when do we actually use our KNN? KNN can be used for both your classification and regression predictive problems. You already saw that. However, it is more widely used in classification problems in the industry. To evaluate any technique, we generally look at three important aspects. One is your ease to interrupt output, calculation time, and your predictive power. This is where we are using our KNN. Okay, now we have something called as your KNN pseudo. What it is? What happens is, in programming languages like Python and R, now these languages are used to implement your KNN algorithm. Following is the pseudocode, how we implement your KNN in these programming languages. First, we load the data. We choose the K value. Once the K value is chosen, for each data point in the data, we find the Euclidean distance for all training data samples. We store the distance on an ordered list and sort it out. We choose the top K entries for the sorted list. And we also label the test point based on the majority of the classes present in the selected point. That is your end. This is your pseudocode. Guys, even we proceed further, we are having some, Python trainings, free Python trainings. And I would request Lakshmi, if you are hearing me, please provide the link for that Python training in the Telegram group as well as over here in the chat as well. That is a free training, guys. You people can join, which we are providing, and you guys can get benefited from that. And I guess it will be conducted by Bharani, who is a product of IIT and ISB. And he's having around 16 years of experience, and he's a chief data scientist in many organizations. So you will be gaining a lot of knowledge when you will be attending a session. So yeah, if you people want to, you can attend those sessions, and I would request Lakshmi to follow the link for that in this group. Okay. Yeah, the link has been shared. And the people who have been asking for the codes and the data set, Rakesh, was that you, Rakesh Kawali? You are asking me the codes and the data set, if I'm not wrong.
Yes, sir.
Yeah. Rakesh, please send your email ID to me, or the people who want these codes and the data sets which I have been using. Please share your email IDs in the chat window, and we will be sharing these codes and the data set to you guys. Okay.
Okay.
Yeah. Thank you. Please ping your email IDs, guys. Whoever want the data set and the code which I have been using. Okay. Moving ahead. Okay. Thank you, guys. I'll be sharing it soon. Okay. Okay. Now, let us see that what are your practical implementation of KNN in cybersecurity. Or if we talk about this scenario where we can use the cybersecurity is, here I've taken this example of cybercrime detection. Cybercrime detection. This is the example which I have taken. So what is actually happening over here is, guys, that just a moment, guys. Okay, sorry guys, management call. Yeah. So what is happening today nowadays, guys, is that today the entire world is confronting some or the other crime, right? And the increasing population has aggravated the issue all over. The launch and the implementation of ICCs in every work culture have reformed the society into a huge modernized and tech-savvy one. So what is actually happening is this, sorry, this information society, this is a pool of your huge opportunity. So we have this challenge of detecting our cybercrime over here. Everyone is using cell phone. Everyone is having, your social media account and talking to this cybercrime. I guess most of you people are, having the Netflix account. There is this particular, documentary on Netflix or, which has been released called as your Tinder Swindler. How many of you watched this series? Anyone? This documentary? Anyone who has watched Tinder Swindler in the participant? No? Okay. So what actually happens over here, guys, that, there is a guy who is having an Instagram account, which is actually a social media account. And on this Instagram account, what happens is he poses himself like a very big shot. He is the son of a very renowned person. They are having some oil fields maybe in Middle East, and he is minting a lot of money. And then what he does is he talks to the girls on this Tinder platform, which is a dating app, and he has these photographs, which these girls who talk to him, they watch over his photographs either on Tinder and Instagram, and they get influenced by. And when he starts dating them, then he gives them, a lot of gifts, treat them like the princes. And gradually, what happens? He asks them the money. He says that, what, my assets have been frozen by the government, and I need some help, and I will return you this, that. And he used to con these ladies who already got influenced by his, influential Instagram or your Tinder account. He is, making some sort of cyber crime using your social media account. So, talking about all these scenarios, it is very, difficult to detect your cyber crime. Hence, what happens is we are using KNN for this purpose. So KNN is helping us a lot when we talk about cyber security and cyber crime things. Okay, moving ahead. Use of KNN in cyber security. Now, what happens is in digital age, cybercrime is spreading its root widely. We know that. Internet evolution has turned out to a boon as well as a curse for these confronting the issues of privacy. Right? I told you this example of a Tinder swindler. Privacy is getting hampered. National security, social decency, IP rights, child protection, fighting, detecting, prosecuting cybercrime, all these things are the examples. Hence, these arise, they need to detect the cyber criminal. Cybercrime identification utilizes data set that is taken from CBS open data. And this is where we can use our KNN to detect all these kind of various cyber crimes that is been occurring these days. Okay. Even before I get to that or this, I want to throw some more light on this KNN thing. Now, consider there are two groups. Say there is a group A and there is a group B. To determine whether a data point is in group A or group B, the algorithm needs to look at the state of the data points near it. If the majority of the data points are in group A, suppose we have some data points like this, like this, like this. What will happen is it will eventually, the algorithm, it will look at the states of the data points near it, data points near A. If the majority of the data points are in group A, it's very likely that the data point in question is in group A. And vice versa. If majority of the data points are near your B, then it is going to be in group B. In short, KNN involves classifying a data point by looking at the nearest annotated data point, also known as what? Nearest neighbor. Okay. Now, we shouldn't confuse KNN with, K means clustering. People get confused when we say KNN and K means clustering. K means. Both are different things. Right? KNN is supervised classification algorithm. This is what? Supervised classification algorithm that classifies new data points based on the nearest data points. Remember the example A and B, we were seeing data point, data point, data point. Whereas if we talk about your K-means, this is an unsupervised clustering algorithm. Unsupervised clustering algorithm. What happens over here? It groups the data into k number of clusters. There is a difference, guys. So don't get confused between them. KNN is your supervised. K means clustering is your unsupervised. Oh. Then one more difference I would like to tell you guys. And this difference is, say, between your KNN and SVM. SVM. SVM, guys, is less computationally demanding than your KNN. And it is easier to interpret, but can identify only a limited set of patterns. There is some constraint on it. On the other hand, if we talk about our KNN, KNN can find a very complex pattern, but its output is more challenging to interpret. If I were to give the conclusion, your KNN algorithm, it is one of the simplest classification algorithm, guys. Even with such simplicity, it can give highly competitive results. KNN algorithm can also be used for regression problems. We saw that regression as well as your classification. The only difference from the discussed methodology will be using averages of nearest neighbors rather than voting for the nearest neighbors. We saw that A and B. Take an average. Majority of them are falling into A. We will take it into group A. Majority of it is falling into group B. We will take it to group B. But now the question arises how to choose the optimal value of K. That is also a question. How will you choose that? What optimal value of K? Now, if we talk about choosing the optimal value of K, then there isn't a specific way to determine your K value. There is. In other words, the number of your neighbors of K. Yeah, K value is nothing but your number of the neighbors in K. This means that you might have to experiment with a few values, deciding for which one to go forward with. One way to do is by considering that a part of your training sample is unknown. Then you can categorize the unknown data in the test data by using your K algorithm and analyze, how good the new categorization is by comparing it with the information you already have in your training data. We discuss about your training data and various steps when we do the data splitting. Guys, kindly be on mute. Okay. Now, when dealing with the two-class problem, it is better to choose an odd value for K. Otherwise, what will happen? A scenario can arise where the number of the neighbors in each class is same. Also, the value of K must not be a multiple of the number of classes present. Another way to choose the optimal value of K is by calculating the square root to the effect of the square root of n. And what is n? N denotes the number of the samples in your training data. This is how you can choose your optimal value. And with this, we are done about enough discussion about KNN. And even before I start explaining you about the business problem which I have solved, there is one more thing about KNN. You know what? People say that KNN lazy algorithm that one heart. People say this about KNN. Why they say that? Because despite being the laziest among the algorithms, KNN, guys, is having, or you can say KNN has built an impressive reputation and it is a go-to algorithm for several classification and your regression problems. Now, of course, because of its laziness, it might not be the best choice for cases involving your large data set, but it is one of the oldest, simplest, and the accurate algorithms of all time. Training and validating of an algorithm with your limited amount of data can be a Herculean task, guys. But there's a way to do it efficiently. What that is called? That is called as a cross validation. And it involves reserving a part of your data, training data as your tested data. So KNN, though it is your, lazy algorithm, but again, it is very helpful, very helpful. Okay, now let us go to our problem. And what I have done over here, guys, that I have tried to build a network traffic classifier, which will tell us that, if a given event is, a malicious event or it is a legit event, I have tried to do all this. What all things I have done? I have done your data pre-processing, EDA, model training, and hyperparameter tuning. That data set which I have used, that is an open data set, guys, called as your cyber attack. And here I have loaded the data set and the required, libraries and all these things I have done. Then I took the data.head. I have, initialized the columns as well. These were the columns that I needed. Duration, protocol type, service flag, all these things are the columns I have created, and I have read the data set over here. This is the data set which was easily available, called as your cyber attack, and I have used it. Again, this is an open data source. And when I say data.head, it is going to give me a top 5 group. We know that. This is what I have done over here. Now, when we start with the EDA, I am setting my data.shape, and I know there are 49, 4,94,021 your rows and 42 columns we are having. Null values I'm trying to find out, and I'm trying to get the sum of that, all these things I'm doing. And now when I say data.dtype, this is all the value which I'm getting. Service is an object, flag is an object, num field logins is your int64, all these things I'm doing. Now I am trying to plot a bar plot over here for my analysis based on this information which I have gained upwards, and for that I have imported matplotlib over here. I am using your advanced graphical representation library called as a CBOT. I am setting the parameters over here that the style is going to be your dark gray. Figure size I am giving 12,8. Font size I am giving. All these things I am giving the labels, whatever the thing should be, what should be the plot title, what should be the label on my y-axis, what things should be there, everything I have mentioned over here. So count of attacks and normal events. This is what I am getting over here. These are the various columns which I took over here, labels, and these are your count of the attack. And this is the bar plot which I have plotted using this particular data set. Then what here I have done is I am trying to group the labels by saying that data.group by, and I am trying to do the grouping by protocol type, taking the count, sort values, wherever there's a false, ascending, all these things I'm doing. Rotation time I'm taking 45, and then again I'm plotting this bar plot, and this is what I do. Compared to this one, this particular bar plot is giving me more information. Labels of your, by protocol type, because I am grouping by what? Protocol type. All these columns were there. I have tried to group it by various protocol types. And what were these protocol types? It was ICMP, it was protocol type, and it was TCP, and it was UDP. All these were the protocol types. Again, on the y-axis, I am having the count number, that in ICMP how much attacks were there, or TCP how many attacks were there, UDP how many attacks were there. Now in the first model which we were seeing, our first model is going to be a binomial one, the first one which we are going to create. So what we are doing over here, from here on, we are going to map anything that is not normal to attack. In the next data analysis will be based on this transformation only. What transformation? We are trying to map anything that is not normal to attack. So here, this is what I am doing. I am using remove underscore dot underscore normalize, and I'm removing your dot from the label and convert anything that is, not normal to attack. Else attack. This is what I am using. Return label if label is equal to normal, else attack. I'm putting the condition over here. I'm saying data label. Again, I am putting your using your lambda function over here, and all these things I am saying. And I am saying initializing two parameters. One is for normal and your attack. Now here, if you see, the class balance is given, and these are your various initializers which I have given. On the X label, what it is going to be, on Y label, what is going to be your plot title, all these things are there. Now this is the more better way to see. Normal attacks, how many were there, and attack normal conditions, how many, and attack condition, how many were there. Even there is something called as your cat plot, which I have done over here. I have initialized the parameters over here, and number of connections to the same host as your current connection in the past 2 seconds over here. Wherever I am having blue dots, it means it is normal. Wherever I am having orange dot, it means the attack has been observed over there. By seeing this graph, what we can see is that there seems to be a high number of malicious events that happened with what in your TCP and ICMP compared to your UDP protocol. Having a number of past connections to the current host within your last 2 seconds. That's a column that already exists within a data set. We know that column is already existing in that data set. So here again, I am trying to plot a cat plot using all these parameters which I have given over here. Here I am having a cat plot. See, y is equal to num file creation. All these file creations which I have done over here. U labels, all these are the parameters which I have taken. By num chunks I have created, and this I have created, means these are the various observations which I have made over here. And now the end thing is there's a slight positive correlation between them. When we compare your TCP protocol, then we see that there's a slight correlation between your TCP protocol malicious event and a high duration of the connections between the user and the host. We can observe that. Now, I have used something called as your, logistic regression, which I wanted to show you guys. Okay, before going there, even before going there.
Hello, sir.
Guys, yeah, Rakesh.
What is ICMP, sir?
These are just the labels. ICMP, TCP, these are the labels on which basis we are trying to identify that either in ICMP or TCP, on which label we got most of the attacks. That is it, nothing comprehensive. These are
What is the full form, sir? ICMP?
ICMP, you tell me, you are attending your cyber security. Anyone? What is the full form of ICMP? ICMP, TCP.
TCP means transmission control protocol, I think, sir. Transfer the data.
What is the meaning of ICMP? ICMP means nothing but your internet control message protocol. That is it.
Okay.
Getting the point, Rakesh? Yeah, Rakesh?
Yeah, got it, sir.
Okay. Here I have done my encoding, guys. I have taken this, I have tried to create feature vector and target vector over here. I am saying that data.drop labels access is equal to 1 means on the columns it is going to do this. I am saying y is equal to data label. Then I am creating the constraint features over here, which are your num outbound and CMDS is host login. then here those two columns which are having no variance means zero variance. Thus, there won't be any use of the model. We know that if we are having a data set and the same value is getting repeated multiple of times, it is going to give us, either zero variance or no variance. And since it is giving us no variety, then there is no point to use it for our model. It is not being helpful for us. So what I am doing, I am dropping those variables which are giving us no variance. This is what I am doing over here. Now I am encoding your categorical columns and split data over here using your sklearn model. This is what I am doing. I am encoding my target variable over here using your label encoder. And then I am using my fit underscore transform to transform my file. That is it. And these are your various encoding predictors which are having. I am using your dummies to get the dummies on your protocol type. I am trying to get your dummies for service which is in data frame. I am going to get your dummies for your flag column and the prefix are B. This is what I am doing. Now, once this is done, I am splitting the data into your trained data and testing data. Why? Because since our data is in place and we want to stratify, and this is how I am going to split and do all this. Here I am conducting the ANOVA test for your feature importance type. With sklearn feature, I am importing your f underscore classes and I am doing my ANOVA f classification over here. Again, I am plotting a bar. Now, once we have this, what we observe is that many columns seem to have no big relevance to the target. But this method is univariate and sometimes some columns combined with many others have no sense. For now, we are proceeding with this. As of now, we are proceeding with this. Moving ahead. Again, here see, I am using logistic regression. Now, after using the logistic regression on my training data, if I get the prediction, this is what I am getting into. This is what something I get into. Confusion matrix, if I try to plot it, we already discussed confusion matrix. Here we are having few false negatives, that is your 297, and false negative as 1940 over here. But if I try to use your KNN, we have been discussing about your K nearest neighbors as of now. And when you compare these figures with this figure, then you see that your KNN model is slightly better than your regression model, which we have been using. See the numbers over here and see the numbers over here. Here you are getting a much better model. How we got that? From sklearn neighbors, I have imported KNN classifier. And here I am saying that KNN classifier take n underscore neighbors is equal to 2. Only 2 neighbors I am taking. Whatever value I am getting, I am putting it to a new variable called as KNN. Again, I am going to fit this model on my trained data on X and Y. Output, this is what I am getting. Then I am saying Y underscore KNN is equal to predict based on your test data. Print evaluation F1 score, and I have got my F1 score as 0.98111, something like that. And if you want to see this in the confusion matrix, this is what we got. Now, if we see this figure, if we see this figure on the trained data, that is your 0.9581, something like this. This is what we were getting when we were using your, logistic regression. But when we see this evaluation number using our KNN, we are getting 0.99811. By seeing this, we can say that, our KNN is providing us a slightly better result than your logistic regression. So this is what, guys, how you can do your KNN. And here we saw this example or what I have did over here is I tried to predict, I tried to find out that, which field, which network classifier, again, TCP, ICMP, all these were what? These predict that which traffic is going to, legit or which one is malicious. This is what we try to find out over this session, guys. Thank you so much for joining. Let me quickly save the chat so that I can share you the codes and the data set, guys. Yeah. And guys, the link has been shared over here. Telegram link, you people can join and you can connect with that Python training. That is a very good training, guys. I would recommend you guys to attend. Okay. So guys, this is where we are going to stop this session for today. Thank you so much for joining. Tomorrow we will be, not tomorrow, I guess on Monday we will be meeting again, and we will be continuing with our other, algorithms as well. So thank you so much for joining, guys. Have a good day, everyone. Enjoy your weekend and happy learning. Bye-bye.